other friends will be joining. Are they going to join or like they are sleeping or what? So after the last class, any question, any confusion, any question? So I hope no confusion is there. Let me know.
No doubt, sir. No doubt.
Okay, so in the previous class, actually, we have completed the theory portion from this gear module. Also, like some gear problem already we have solved. Okay, so in the last class, we are talking about like different gear trains. There we have basically discussed about. Do you recall the different types of gear trains? So we have basically discussed about your simple gear train and the compound gear train, reverted and planetary gear or epicyclic gear train. So out of this simple and compound gear train, so can you tell me the distinctive features? I will be able to distinguish them. What is the feature? How to know whether that particular gear train is a simple gear train or that is a compound gear train? Suppose the situation is something like this. Suppose these are the gears. Okay, this is the shaft position. Okay, this is a gear, gear A. Okay, and it is in mesh with suppose gear B, which is mounted on this particular shaft. This is gear B. Okay, and let's consider there is another gear which is in turn in mesh with gear B. That is gear C is in mesh with gear C is in mesh with gear B. Okay, maybe the last one. Suppose gear D is in mesh with, so gear D is in mesh with gear C. So can you tell me what kind of gear train is this?
Very simple.
Okay, so this is simple gear train. How do you ascertain that means this is a simple gear train? How did you know? That is what you have looked for and how you have concluded. Yes, correct. This is simple gear train only. Okay, but how you have distinguished it to be a simple gear train? That is what is my question. No, no idea. Basically, everywhere you can see this is on a single shaft, one single gear was mounted. Okay, now let's consider on this particular shaft we had gear D. Okay, and this gear D is in mesh with suppose gear E. Now, what is this gear train? What about this now? Hello, audible or not?
Audible, sir.
Audible, sir.
Yeah, then tell me what do you think? So
Compound, sir.
this is gear A. This is gear B is in mesh with gear A. Okay, gear C is in mesh with gear B, and on this same shaft as that of gear C, we have gear D. And now this gear D is in mesh with gear E. What is this type of gear train? Rishikesh said this to be
Compound, sir.
compound one. Yes, correct. This is compound one. So how did you ascertain that this is a compound one?
Sir, it's a number of gears are fixed together, sir.
Yeah, let's fix together. But how did you know that means this one is a kind of compound gear? That is my question. Compound gear train.
Sir, in compound gear train, number of gears are fixed together, sir.
Number of gears are fixed together. It is not fixed. It is on the same surface it is mounted. If the gears are directly fixed, then they will not be able to have the motion. No? Okay. Fixed element don't have motion, but gears they have got motion. Okay, so fixed means it is on the same shaft more than one gear is mounted. That is what you want to meant to say.
Yes, sir.
Okay, then it's good. Okay, so now today we'll be solving some. We'll try to solve some problem. Okay, we'll start with the basic one, and after that we'll go for epicyclic gear train problem. Initially we'll go for suppose simple gear train or compound gear train problem. Okay, and after that we'll go for. Okay, so now the first question. What does it say? It says that a compound gear train consists of compound gears B, C, and DE. What is this meaning? Compound gears B, C, and DE means that means B and C are mounted on the same shaft, and D and E they are mounted on the same shaft. Okay, so all the gears are mounted on parallel shaft. The motor shaft rotating at 800 rpm is connected to gear A. That is gear A is driver. That means motor shaft is uh, rotating at 800 rpm, and this is nothing but the driver one. Okay, and the output shaft to the gear F. That means the final output motion you are going to get in the gear F, and that is the output shaft. The total number of teeth on gears A, B, C, D, E, and F are given as 24, 56, 30, 80, 32, and 72 respectively. And by knowing this particular gear arrangement, you need to now find out the speed of the output gear F. Okay. So now once this is given, sometimes this question may or may not begin. Just wait. Okay.
So,
Yeah, just wait. Okay. Yeah, sorry. Actually, I got a call from AEC, so that's why. Okay, sorry. Okay, okay. I'll discuss. Okay, I'll keep on discussing this. Okay, so you can visualize see the screen now. The figure you can see.
yes, sir.
Okay. So now, what we'll do based on this, that means we have seen that there are A, B, C, D, E, and F. These are the six gear which are missed, and out of this B and C they are mounted on the same stuff, and D and E they are mounted on the same stuff, and like the number of teeth that is also given. So from there we'll have an idea. That means which one is smaller, which is bigger, or something like that. Okay. So now, sometimes this figure may or may not be given. So even if the figure is not given, from this data you'll be able to draw this. So now it is will consider that they are like uh, in a linear fashion they are there. Okay. So suppose gear 1, gear A we are drawing here. Okay. So gear A is in match with gear B. Okay. So gear B, depending, it is like 50 60 it is there given. So definitely you can automatically understand it is the smallest one, 24 teeth, smallest size. Okay. And 80 is definitely the bigger, and these are kind of intermediate. So we don't have to like exactly draw it up to scale, but at least have an like in the picture it should look, suppose this is smaller, this is bigger, or something like that. At least that much understanding we must have. So next, gear B is in match with your gear A. Okay. And now as from this question we know that B and C they are nothing but the compound gear. That means on the same curve shaft as that of B, gear C is also mounted. This is gear C having 30 teeth. Okay. And now with C, gear D is there. Okay. So this is gear D, this is gear D, and once again D and E they are the compound gear. That means on the same sub they are mounted. So this is E, and gear E is in turn in mesh with gear F. Okay. Now here if you look, so this portion which is we are saying this is in the back side of this particular here. This C and D are in mesh, so B is not in mesh with D. So this portion we are showing with dotted line. Similarly, in this case, gear E, the smaller one, is in mesh with gear F. The gear D, which is on the same sub as that of gear D, E is it is not in mesh with gear F, but rather this gear E, which is in the same sub, is in mesh. So this portion we have drawn with this dotted line. Okay. So now after that, this rest is simple. So we know that if the all those gear number of teeth that is given, so we can have the train value. Okay. So train value we know it's nothing but the product of number of teeth on all the driving gears divided by the product of number of teeth on the driven gears. Okay. So that is not, and that this is nothing but, and F, this is the output we are getting here. This is the input gear. Okay. And this is the output gear. Okay. So train value we can get like, we can draw like NF, the driven by driver. Okay. Number speed of uh, this gear F. Okay. Speed of this gear. And what are the driving gears? Because we need the product of number of teeth and the driving gears, all those driving gears. So which are the driving gears? This is driving gear. A is driving B. Now C is in mesh with D. So now C becomes once again the driving for D. Okay. Also D, this gear is driving for F. Okay. So TA into TC by TE divided by which are the driven gears. So A is driving B, that is B is driven. So from C we are getting the motion on D, that is it is driving D. So D is once again driven. Okay. And E is driving F. So F becomes driven. So divided by TB into TD by TF. Okay. Now rest is just simple. So we need to find out the speed of gear F. Okay. And that is only the unknown that is there. Speed of NA is already given as 800. Okay. And other number of teeth that is already given for all those gears. Okay. So we are just putting them, and from there after doing the calculation we have obtained the speed, output speed to be 57.14 rpm. Okay. So from there what we can say, initially what was the speed of the driving gear, that is A. At A portion, what is the speed? We have got 800 rpm. Now from 800 rpm here as the output we are getting how much? Around 57 rpm. So this is a reduction type gear train. Okay, the final output in a as a reduced value we are getting. Understood? So this is how this is a very simple one. We can obtain this. All of you have understood or not? Let me know. Yes. Hello. No, sir.
Yes,
Or
sir.
suggest not.
Yes, sir.
Understood? Okay. So we'll go for then next problem. This is another problem, small problem. So this came in one of the GATE exam. All of you have heard about GATE, na? Okay. So now, what does it say? It says that a compound gear train with gears P, Q, R, and S has number of teeth has P has 20 number, Q 40, R 15, and once again S has 20 feet teeth respectively. Gears Q and R are mounted on the same shaft, that is kind of compound gear train as on the figure. You need to determine the okay, not determine the diameter of the gear twice that of Q is twice that of gear R. Okay, so dimension relationship is given. If the module of the gear R is 2 millimeter, find the center distance between the gears P and S in millimeter. Okay. So now what they are giving, this figure is now this time it is given. Okay, so this is P, gear P, and gear P is in mass weight which gear Q. Next, it is being said that Q and R are on the same shaft. Okay, that is compound gear train we know. Okay, so Q and R in mass weight S. What they are saying that this number of teeth that is already given. So you'll first write down all those given data. So while solving, you find out given data. Okay, so T of P, Q, R, and as there is given. TP is given, TQ is given. Okay, TR is given, and TS is given. The number of teeth in all the gears that is given. Okay, next what is given? This is Q and R are on the same sub. So in the figure itself, it is already there. Okay, and the diameter of Q is twice that of gear R. Okay, so diameter of Q is given as d of Q is how much? Twice that of R. Okay, so this Q and R, how they are related? So this is twice that of R. So these are given. Okay, so what you need to find out also, the module of gear R is given. Module is given for gear R. Okay, that is 2 mm. Okay, so these are all given data. You'll just write down first. Okay, and what you need to find the center distance between the gears P and S. So what you call understand by center distance? Center distance is nothing but this distance, center to center distance from. Okay, so this much distance in millimeter we need it. Now for that there may be multiple ways of solving this particular problem, as there are like all the speed etc that is given. So you can also use the relationship between the velocity ratio. Also the module value for r is given. Okay, so from there module we already know m equal to d by t, that is known. Okay, module for r is given, te for r is given, so diameter for r which is previously not given, that also we can find out. Once we know about diameter of r, from that we'll be able to find out diameter of q. Okay, once this q is known, so if we also know about the diameter of this p s etc, we'll be able to find out this particular distance by using simple geometry. Okay, after this must it clear?
Yes, sir.
Okay, so now see, there may be like as I have said previously, like there may be different ways of doing it. One may be like by geometrical relationship or velocity ratio, etc., etc. Okay, and also the module. Apart from that, there is maybe another way of solving, because we know if P and Q are in mesh, so their module must be same. Okay, that is the for meshing gas, that is one of the relationship. Similarly, R and S are in mesh, so module of R will be equal to module of S. So there also you can use. Okay, now one we are solving like this. Okay, so we are solving like we know what we know. Velocity ratio we can write like, so this is n2 by n1 we can write. Okay, which is nothing but in terms of the size or the number of teeth, that is the reciprocal of that. Okay, that is T1 by T2, and we know that can also be written as d1 by d2. Okay, so that is normal your velocity ratio thing. Okay, now what is given, the module for r is given, so we know module equal to d by t, diameter pitch circle diameter divided by your number of teeth. So for module r we can write m of r, that is module of r equal to diameter of pitch circle diameter of r divided by the number of teeth in r. Okay, d by t for r. So now what is not known, we don't know about the diameter value, but we know the teeth, that is 15, that is given. So from there also module is given as 2 mm. Okay, by putting that we will find out dr to be 30 millimeter. Okay, now in this question, as per question, according to question, what is given according to question, dq equal to twice of diameter of r. Okay, so dr is known, so the diameter of q become 60 mm. Now, if we think of the velocity ratio between first first P and Q are in mesh, okay. If you try to consider this particular pair which are in mesh, that is P and Q, we can the velocity ratio for P Q, that particular pair, we can write N Q, N of Q divided by N of P, or in terms of the number of teeth, we can write in the reverse ratio reciprocal, that is T of P divided by T of Q. Okay, and TP and TQ, these are given as 20 and 40, and by putting it we can get like 20 by 40 is nothing but half, which itself in terms of diameter is equal to dp by dq, because we know consider ratio like t1 by t2 can be written as equal to t1 by d2 also. Okay, so from here what we can obtain, this half is equal to dp by dq. Okay, so now from here we can simplify, we can obtain dq is already known, this is dq 60 mm, so we can find out dp, that is becomes half of dq. Okay, so this is 30 millimeter. Okay, so similarly for this particular pair, it's r and s, this r and s, they are also in mesh. Okay, this is r, this is s, they are also in mesh. So if we try to find out the velocity ratio expression between them, okay, we can write here velocity ratio for r and s, that pair equal to dr by ds. Okay, in terms of diameter we can write dr by ds. Okay, so this t teeth, number of teeth value it is known, that is for r it is 15, for s it is 20, dr is already known. Okay, that we have just found out dr to be 30 mm. We are putting this, and ds is unknown, which can be found out from here as 40 millimeter. Okay, so now what we know, we know the dimensions for all these gears. Okay, once we know this, then we'll be, by using simple geometry, we'll be able to find out this particular distance. So this particular distance, this central distance ps, how we can write, this is rp, that is the circle radius of this. Okay, rp plus this is s. Okay, this mass, this plus this plus this, right? Okay, and what is this, how much is this, let me like just wait. Okay, I'll just make it clear, I'll just make it good. Okay, let me make it clear so that we can easily understand the thing. Okay, okay, it's almost clear. Okay, okay, so how much is required, we need this particular distance, right? Okay, so for that, if we have if we add this mass, that is r of p, plus this mass, that is r of s. Okay, plus we need this mass, plus this mass, if we add, we are going to get this whole distance. Okay, Now what about this mass? Okay, how to find out? Now this mass is nothing but this total, that is T of Q, the diameter, whole diameter, minus this mass. Okay, so what we can write, this Rp plus this mass Rs plus this whole, that is diameter of R, plus diameter of R, not so sorry, diameter of R. Either we can find out in terms of diameter of R plus this, okay, or the whole diameter of your that Q minus this. That is up to you how you find out. Okay, so in terms of diameter of R, if you write in terms of diameter of R plus this much is required. Okay, or this much, the same thing. Okay, so and this much is how much? RQ, that is this, the whole radius minus R of R. Okay, that will give you this much. Okay, so just by putting that, we obtain as PSS 80 mm. Okay, this may be one way of solving this by finding out all the dimensions for all the different gears, or maybe for finding out using the simple relationship, that means the formatting gears, the module is same. By utilizing that logic also, you'll be able to find out. Okay, understood? Is that clear? Is it clear, Fermiki, Teja?
Yes, sir.
Fermiki is not here. Seems like Fermiki is actually not here. Just he is just joined. Okay, for email. Okay. Okay, so then we'll move ahead. Okay, we'll move ahead and we'll try
Sir,
to solve one problem from. Yes, yes. Someone is saying to say something. Please just ask. No problem. You can ask your doubt, whatever doubt is there. Okay, now no one is saying anything. Okay, so whatever. So now, this kind of problems I hope you will be able to solve by using the relationship and all, non-relationship. Now we'll go for solving problem from epicyclic gear train. Okay, as we have previously discussed, there may be different varieties of epicyclic gear trains. So now in this particular question, what is being asked? Let's try. Okay, so the question statement says, problem statement says, an epicyclic gear train, it consists of a sun wheel S is the sun wheel, okay, a stationary internal gear E, okay, that is the outer internal gear, okay, and three identical planet gear wheels P, which are carried on a star-shaped planet carrier C. So the carrier shape is also given and carrier name is C. The size of the different tooth wheels are such that the planet carrier C, it rotates at 1/5 of the speed of the sun wheel S. The minimum number of teeth on any wheel that is acceptable is 16. It is given that the driving torque on the sun wheel is 100 Newton meter. You need to find out the number of teeth on different wheels of the train. Also, you need to find out the torque necessary to keep the internal gear stationary. Okay, so in this question, the figure is given. Okay, so here as you can see, so this is the sun wheel S. Okay, and we have got three identical planet wheel P on it. Okay, this is P, this is P. Okay, and this is P. Okay, and what is the internal gear or the annular gear? This is the outer annular ring or annular gear, or this is the nothing but the internal gear, because it has got the internal teeth onto which those planar gears, okay, they are in mesh. Okay, this is E. Okay, now what about the arm? So arm is called, it is said that the planet carrier arm is a star shaped one, and it is C. Okay, so this is planet carrier, so it is holding all the three planet gears pivoted here at the center of the planet gears itself. Okay, and it is pivoted here, and arm is also is rotating about this center of this particular sun gear itself. Okay. C is the carrier. Okay. So what are those? So we have drawn the sun wheel F. Okay. So the stationary internal gear, this is the condition that is given E. Okay. And these all this P, these three planet gears are identical inside. Okay. And it is carried on this particular star shape, as you can see, star shaped one. Okay. Star shaped planet carrier, and this is given by C. Okay. So now as for the question what is being given is, so the size, okay, or I can say ultimately the speed, okay, speed of those different elements, which is a kind of nothing but which has got a relationship with the different sizes of the other gears as well as the number of teeth that is there on that gears. Okay, it is such that the planet gear C, it is rotating at 1/5 of the speed of the sun wheel S. Okay, and the minimum size for any wheel it is given, and the driving torque for the sun wheel is given as 100 newton meter. So from this relationship you need to able to find out the number of teeth on different wheels, also the torque necessary to keep the internal stationary. Okay, so for this kind of problem with respect to your epicyclic gear train, as we have previously discussed, we basically make a table. Okay, we do in a tabular way, and we make the table by showing the motion of various elements under different conditions of motion. Okay, so in that case, what are the different elements present here in this particular system? So we have got this particular arm C, which will have some particular motion, which will influence the motion of other elements also. Arm C. We have got this annular ring E, okay, another gear E. We definitely have this sun gear S, okay, the sun gear S, and we have got three identical planet gears. Okay, so everything is identical here, and they are also this all those three planet gears, they are identical in shape and number of teeth. Also, they are in mesh with the same two sun gear, same sun gear as well as the same itinerary. Okay, that means the condition of motion for any of either of these three gears, if you know, then it is the same for all the three planet gears. Okay, everything is identical. So while I'm doing the analysis, what we can consider the different elements we'll consider, like one is the arm C. Next, we'll be considering the bigger annular internal wheel E. Okay, we'll be considering any one of that particular planet gear P. Also, we'll have to definitely consider the sun gear S. Okay, so in this case we'll be making that particular table, and that table is for the motion of various elements. And in that case, in one of the column we consider the different conditions for motion. Okay, and under that influencing condition of motion, what happens to the motion, or what kind of motion is being gained by all the different elements present in this particular system, that we try to see. Okay, so now in this particular column you have seen, like, we are considering the conditions of motion, and after that in the subsequent columns we are considering all the different elements starting from the arm. Okay, arm C, then the wheel E, gear E, one of the planet gear P, okay, and the sun gear S. Okay, now first condition of motion, what generally we consider? We generally consider one of the consideration is we initially consider the arm is fixed, and we try to give one rotation. So we are considering the arm to be fixed, and gear E is rotated through plus one revolution. Now this plus one, or whether you are going to consider minus one, that will be dependent on the sense of direction. If suppose you say, suppose anti-clockwise, if you are considering positive, then if you are getting the direction to be in the clockwise direction, then you have to definitely give negative sign for the other sense of motion. Okay, so that is up to you. Initially, whatever you consider, if you consider clockwise to be positive, then anti-clockwise has to be considered negative, and vice versa. Understood? So now let's consider arm is fixed, and you are giving the gear E a plus one revolution to E. Okay. So what we have to write, what will happen to the motion of the element? So arm C, it will be 0 because arm is fixed, we are considering. Okay. And we are giving one revolution plus one revolution to E. So gear E, this is plus one. So now if you now look at this particular figure, so you can say this gear E is in mass with what? So if the gear E rotates, so it is in direct contact or direct mesh with which gears? You can tell me. With gear E, what are the gears that is in mass with gear E? Or due to the motion of gear E, which element from this system will get motion? From motion transfer will happen to where? You can tell me. If you look properly, so this planet gears are in mass with this internal gear E. Okay, so that is the thing. Yes or no? Hello.
Yes, sir.
Yes, sir.
Okay. So now, if they are internally meshed, what is the sense of direction? Will it change or the gear P will rotate in the same direction as that of gear E? What about internal meshing? They move in same direction or opposite direction? Both the mesh gear. What happens there? Internal gears. So they rotate in the same direction. You have already forgotten all those things. Okay, so same direction means same sense of rotation, that is plus only. Okay, or if you don't write anything, that automatically means plus. So what will be, so from this motion we will be getting motion in P, the planet gears. Okay, and how to get it? So this is nothing but TE by TP in terms of the number of T. Okay, now from P, if P is rotated, P is in once again in turn mesh with the sun gear S. Okay, and this is what kind of meshing in P and in between P and S, external meshing or internal. The smaller gears are P. This is P. This bigger, this one. The at the center, the gear is S. They are what, external meshed or internally meshed?
External, sir.
External. So now in external meshing, what happens if one of the uh, this is rotating? Suppose the planet wheel is rotating in the anti-clockwise direction. What will happen to the sun wheel? Clockwise direction or anti-clockwise? External meshing. What happens in case of external meshing? Both will rotate in the same direction or in opposite direction. See, the whole
Opposite
module is
side will
about
be
to
bright.
over. If you don't know in external mesh what happens, okay, then who can save you? Yes, tell me.
Opposite, opposite
Yes,
side.
yes, opposite direction. Okay, so that means whatever will be the sense of rotation for this particular planet wheel, it will be the opposite sense of rotation that we will get in this particular sun wheel. That means if previously this is positive, now we have to consider negative sign. Okay, so now what happens here? So initially from E, the motion we have obtained in P. Now from P we are getting the motion in S. Okay, two stages. Okay, so for gear S, what is the motion? So we can write TE by TP. This is somewhat like this. Now from here we are getting in the S wheel. Okay, that is T into TP by TS. So after simplification we can get this is equal to negative of TE by TS. Okay, this is the motion in S. Okay, up to this much understood?
Yes, sir.
Okay, then rest is simple only. Rest is what we'll do. Previously, have just considered a plus only one revolution. We'll just extend it to any number of revolution x. Okay, so same thing. Arm fixed. Gear is now rotated in rotated through plus x number of revolution. So just x has to be multiplied with this unitary rule. Okay, just for one revolution, this is the value. For x revolution, we'll just multiply x with this. Okay, 0 into x 0, 1 into x x. Okay, this is x into t by tp. It is minus of x into t by ts. Up to this much, I hope that's also clear. Now what we are doing, we'll just give motion to the arm also. Okay, we are just considering as if y motion is revolution is given to arm. Okay, and for that we are just giving adding y to all the elements. Okay, to all the elements we are adding total the other next motion. Okay, because we know in epicyclic gear train, so it rotates about the its own axis apart from it also revolute okay, around that also. Okay, so y, we are adding y to all the motion, okay, to all the elements. Okay, so 0 plus y equal to y, so x plus y equal to x plus y. Okay, this plus y equal to y plus this. Okay, and the total for the gear S, it has become y minus this. Okay, so this is the, in the tabular form we are finding out in terms of suppose x, etc. What should be the type, different types of motion that will be there. Okay, in the race case, what we'll do? Okay, today we will not be solving the next part. Okay, so later what we'll be doing will be just relating it with, because we have obtained the motion for all the elements in this expression. Okay, now these expressions will try to correlate with the given condition. Okay, in the condition, if it is given, suppose the element motion of this element is this mass, or motion of that element is this mass, so this will try to equate all those given conditions. Okay, and after that, if we solve for suppose all those values, then we'll be able to get the other option. Okay, so with this we'll stop here for today. Next part of this particular problem we'll be solving in the next class. Okay, up to this much, up to today's class, you have understood, no? Yes or no?
Yes, sir.
Okay. Then respond to your name calls. Nilut Paul,
Present, sir.
Shankar, Shankar, absent. Arshishman,
Present, sir.
Rehan,
Present, sir.
Partha,
Present, sir.
Partha, Rishikesh Basumatari,
Present, sir.
Fermiki,
Present, sir.
Nohasol,
Present, sir.
Heza,
Yes, sir.
Rishikesh Nath,
Yes, sir.
and Emil. Emil, Emil seems absent. Okay, so thank you, everyone.
Thank you, sir.
Thank you, sir.
Abang episode dia. Dia. Temannya ada lens ya. Ada. Oh ni bersengaja lihat ni tu breed dia ni kan? Uh, oh bersengaja. Cuba. Cuba. Lola. 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 Come cut me, man. Abang. Come cut me, man. Hmm? Lazy, man.